Okay. I think before we start our talk today, I would like to give a brief introduction, to our speakers today. Dr. Taki, Ediene Seghier. Am I spelling correctly, Doctor?
Yeah, correct, very
Yeah.
correct.
Okay. Obtained his PhD, he's getting his PhD from UTM in 2019. I mean, for those who's coming from Indonesia and others parts of the world, UTM is one of the oldest architecture schools. Not the one of the oldest, but it's the oldest architecture school in Malaysia. So it was full with lots of experts from that universities. He is eager to teach and learn more about sustainable building design practice and BIM related topics. So Dr. Taki was expert in the sustainable buildings design practice and also BIMs. Those are his expertise. He was passionate to teach about how to utilize technology in AEC industry base. He was honored to be the laureate of 2 national prizes in architecture and several scholarship in his career. His experience in academia, including working as a teaching assistant, his assistants, invited speakers. His expertise focused more on green building, in building information modeling, green BIM. He is certified by Autodesk as a Revit professional and has strong knowledge of several other BIM software, such as Dynamo and Navis Works. His past research works were linked to the construction and building industry, several tools, and he has developed, the one that developed could be patented soon. So Dr. Taki has lots of experience. For those who planning to do modeling, experiments, those things, I think you can ask him on the details of or things to consider for the research. Without further ado, I think I would like to invite Dr. Taki to deliver his lectures. Please, Dr. Taki, the time is yours.
All right, thank you, Prof. Nakula. All right, good morning, everyone. Assalamu alaikum. So my name is Taki. I really want the class to be, you can hear me, right? Everybody can hear me, right? Okay. So I really want the class to be kind of not me just talking passively. I really want participation, even though it's online. I know it's a bit hard to do it. In fact, yesterday I asked Prof. Nakula if possible to do the class physical, but he mentioned we cannot. So at least, if possible, please, I really want to see your face because I don't even know you. So how can I, especially those that are studying UCSI, it's good actually, maybe in the beginning, at least I see you and ask you, what is your research topic? So I cannot teach without knowing you actually. So please, if possible to switch on the camera, at least in the beginning, maybe when we start presenting, no need. But at least in the beginning, I really want to see you. Yeah, please, we are waiting. Okay, nice. So I can see one guest, I think from, okay, this is my student. I know this guy, no? Abu, right?
Abu.
Okay.
Welcome, Abu.
Okay. Please, others, if possible, please. All right, good. Muhammad, where are you from? Muhammad Hussein?
Good morning. I am from Jordan.
Good morning.
Good morning.
Ah, nice to meet you. All right, good.
Nice to meet you.
So you are doing PhD in UCSI, right?
Yes, yes.
Okay. I'm from
Muhammad is in the first semester.
Okay, I see. Okay. Can I know at least what is your interest in terms of research? Are you interested in social-based research or research related to simulation and modeling, or?
Yeah, of course, Doctor. I have a background in geomatics engineer and regional planning in master, and have an interest in sustainability and using and I will build model for harvesting and flood flash flood and about the sustainability of building and urban greening and in this sector.
Okay. All right. I understand. Okay.
Huh?
Yeah. Okay. Good.
And
All
I
right.
can using
Hope you will.
the remote sensing and GIS and another geomatics tools and techniques to build and this model يعني about this sector.
Okay. All right. Good. Good. It seems you are interested more in the urban scale based on what you mentioned, not the architectural
Of
scale.
course, yes.
Yeah. Okay. Anyway, that's good. Let's see, please. Someone else, like those from China. I know there is some student from China, right? Or if you wish, you can write. Actually, if you don't want to, yeah, because like this, it's for your benefit. Actually, if you switch on the camera and you engage with me, it's better for you, not for me. Of course, even for me it will be, but you know, in the end of the day, it's your very valuable time now is to get benefit of this. Please, others, are you here? Those in China? Wu Zhang Zhu something? Okay, I think I know you already. Okay.
Nur Hazwani is there. I think Nur Hazwani
All right.
is doing research on simulations.
Okay. All right. In the beginning, I will start by a quiz, actually, just to see if you know specific points. So I will share screen, and please go to Kahoot. I believe you know Kahoot, right? So it's written here already. So join kahoot.it and use this pin number. So I'm waiting for you here. So I need to see you here, and please put your name. Don't put A or B or C. Put your name so we can see you here. Just 7 questions, just to get an idea of regarding your understanding, because I've never taught you. I have no idea about. Okay, so Abu here already. Please, others. So go to this website. Then the game pin is this. Okay, good. Please, others, we are waiting for you. Go to this website. Even Nakula is here. Please, others, quickly, so we can start. It's just 7 questions. So if you miss one question, it's already 10%. If you don't know, please mention this in the comments. So you need to be interactive, please, because I can see only 4 here. So this last call, please join this Kahoot. So go to this website and put the pin of the game. All right. So basically, remember today's sharing title is basically building performance research design. So simulation versus experimentation. Okay, I think I will start. Those that didn't join, I will just start. Sorry. Okay, so only 7 questions. So it doesn't mean if you don't know the answer, it's a problem. I'm just trying to assess what do you know or what do you think about this, for example. So building performance simulation results are accurate about 90 to 99% when compared to reality. Is it true or false? What do you think? If you do daylighting using computer simulation or you do daylighting using measurement. So if you compare the results, do you think it's really accurate to this extent? Anyway, so only 2 answered, or sorry, only 3 answered, and those they said yes, it's not yes actually. So if you don't know computer simulation, you might think that computer simulation is very accurate. In fact, it's not accurate actually, but even though it's very powerful tool in the hand of those they do research in the built environment, but you really need to understand that it will never, at least until now, it has never reached the accuracy of measurement actually in reality. That's why generally we combine experiment and simulation. Generally, research that are based on simulation only, most of the time they are not really accurate. Anyway, so just keep this in mind. I will continue. So please participate, not only 3. So Radiance and Energy Plus are respectively what? Are they daylighting and energy simulation? Or energy and daylighting simulation? Or daylighting and energy simulation engines? Or solar radiation and energy simulation engines? So these 2 things, Radiance and Energy Plus. Please participate. Only 2. I can see the only 30 seconds. Remember, in Kahoot, you have time. Okay, it seems we have already 2 students. They know what is Radiance and Energy Plus. This gives me the opportunity to know also that some students, they know this kind of things, because this is very helpful for me. Otherwise, I will keep explaining things you know already. So anyway, so Radiance basically is a daylight simulation engine. And Energy Plus is an energy simulation engine. So if you want to do energy simulation, you need to use Energy Plus. So here, in the options I'm giving you, for example, this one is similar to this one. Here I'm saying it's a software, and here I'm saying it's an engine. So the correct answer is an engine, not a software. Later in the presentation, I will explain more about what is engine and what is software. So don't worry about that. So I'm not sure if you are familiar with this typical methodological year data. I know this is a difficult one, so if you are not familiar, it would be very hard to choose. Don't worry, yeah. During the presentation, I will go through this. I just want to know if some people they know this already. These others, okay, we have 4 answers already. I know many that are just guessing randomly. Okay, so this one, of course, basically you need to read it. So it's not even if you get it right, it doesn't mean you are intelligent or. So basically, there is something we call it weather data. If you heard, so because generally in computer simulation, in order to run a daylighting simulation or energy simulation, you need something called the weather data. And these weather data that are measured in what we call a typical methodological year, TMY. And this typical methodological year basically is measured in 12 years. So they use weather stations. Later on, I will explain in the slides. They use weather station for 12 years to collect data that you will be able later on to use in a computer simulation. I can see nobody got it right, but it's okay. Even yeah, it's a bit hard to unless you read it before. So maybe some of you, those especially in Malaysia, maybe they are aware. Others, I'm sure they are not aware which standard is usually used in Malaysia. So in Malaysia, they have MS. It means Malaysian standard. and they have some numbers like this coding. And for energy simulation, there is one of these is usually referred. So if you are working in the practice, you know it's ready. I think Abu already know this, which one. Okay, so I can see some 2 students, they selected this. Yeah, so this is correct. So if you open this standard, basically it's regarding energy, not only energy, actually, it's regarding like green building performance. So even OTTV is actually in this standard. Of course, energy is there also. So what is the baseline design in building simulation? So if anyone happened to run any simulation, I believe you will be familiar with the terminology baseline. All right, very good. I can see already 3. It makes sense for them. What is a baseline? That's good. So basically, baseline is a design that we use to compare its performance with the new design options. So generally, later on, when I show you the framework, how simulation works, in fact, even in the research, so if you want to publish a paper or if you want to, even your thesis, generally the overall research design is the same. You will see always we need the baseline, and after that we create design options to compare them against the baseline performance. After that, we decide which one is the best design option in terms of performance. So good, already 3, they have an idea about baseline. That's good. Which option is not a design variable? So this question, I want you to make sense of what is a design variable. Because in computer simulation, we mention design parameter, design variable a lot. Remember, I'm saying it's not a design variable. Which one? Okay, that's good. I can see we have good students. They know actually. They make these things. They make sense for them. Okay, that's good. All right. I think I will not comment on this because the next question is similar to it. So better to. So now design objective. Which option is a design objective? This is the last question, by the way, I think. Wow. Okay, this means we have students, they really design variables and design objective, they make sense for you already. That's very good. So as if you have noticed, generally a design objective is about minimizing something, right? So it's either minimizing, for example, the cost, or maybe maximizing the comfort in space, or maximizing the daylighting in the space. So you cannot say maximizing daylighting is a design variable. It's an objective, right? It's a performance objective. So these things, they really need to make sense with you. All right, so I think this is the last one. I already finished. Yeah, so basically here is Abu, because he's from Malaysia, so he's familiar. Okay, you are 3. You are familiar with the, they call it Malaysian standards, that's why. Who is Hani? Who is Hani here? Huh? I want to know Hani. So Nankula is second also. Okay, that's good. Yeah, I will continue. So now we start with our lecture, or our presentation regarding today's. Remember, when we prepare a presentation like this, we really spend a lot of time making things make sense for you. So please, if you are using your phone, I think it's not a good idea. Better really to give some importance for your time now. Try, especially if you are research or you are planning to do research in this field, it's really good thing. I can tell you, I remember when I was studying at UTM, I was always complaining why in the research methodology they don't show us some like research methodology related to building performance. Always it's about questionnaire research. It's about entity review. So I complained many times. So today I'm a lecturer and I'm trying to not make the same. I don't want to feel the same thing like you. So that's why I'm designing this sharing, which is related to building performance. Okay, so basically, I believe you can see the slides, right? Okay. So basically, the audience for regarding this sharing, basically, it's either a PhD or master students. So either architecture or engineering, also because usually simulation, you know, it's not actually used only in architecture; is really used in engineering as well. So the objective is to provide an interaction about the foundation of building performance research design. I hope you will enjoy it. So at the end of this sharing, you will be able to first to understand. Okay, let me make this pointer. So to understand the importance of computer simulation and field experiment in architecture research. And the second objective is to understand the key advantages and disadvantages in both methods. And last but not least is to understand the overall research design in building performance. Okay, let's start. Let's go. So one of my favorite books actually is this book, and it's called Research Method in Building Science and Technology. And this is a very recent book, I think in 2022, authored by this two authors. So if you take a look here, so as you can see, the main heading here is the research method in building science and technology. If we take a look, for example, research method in daylighting and electric lighting. Let's say you are interested to do research related to daylighting. So it's very good to know or to have an idea about the overall what is happening in that bulb of research. So in this research, according to the authors, basically there is three niche, you can say. So the first one is determining and evaluating the quantity and distribution of light. If you want to do any kind of research under this, so basically if you have any problem, research problem under this one, so basically you can either, for example, go to sub niche, which is physical measurement of light and quantity. So this means basically this is an experiment, right? You really need to go to the site or you need to go to your project. I mean, a case study, for example, and you can, for example, measure the photopic and colorimetric variables. You can apply this circadian light measurements. You can utilize measurement in field and laboratory research. Remember, when we say experiment, the experiment can be done in the field, right? Like a case study, or it can be also done in laboratory, right? Generally speaking. So this may be, it depends. So as a researcher, you need to decide if you think laboratory is the best, because generally laboratory we can really control the environment, right? For example, nowadays we have an artificial sky. Of course, it's very expensive to have it. Not all the universities they have it, but it exists. So this means you can put a model in this artificial sky and do your studies through experiments, not through simulation. And another niche under this, daylighting research, determining and evaluating the quantity of daylighting distribution, is computer simulation of lighting quantities. So some researchers, they have the option to actually to run simulation. As you can see, simulation can be computational simulation of photopic and colorimetric quantities, similar to this one, but this one is measurement and this one is simulation. It can be computational simulation, circadian quantities computational. So basically, it's the same as this one, but instead of measuring using devices, we do simulation in a computer. Or it can be utilization of computer simulation in research. So in general, I will not. Of course, there is other sub fields. You can actually even go, for example, to machine learning. Nowadays, you know, you can hear about ChatGPT and this Mid Journey and many softwares, Blab of Google. So there is this area is very hot actually. If you apply machine learning in daylight in research and maybe you combine it with simulation, for example, it's really very hot research area nowadays. Of course, you can focus probably on optimization, so you can apply algorithms to optimize your design as well. Yeah, okay, let's jump here. For example, determine human psychological response, visual comfort, and performance. As you know, when it comes to daylighting, basically we can measure the quantities and also we can assess the quality of daylight, right? So if there is a lot of glare, it's an issue, right? That's why glare is part of, you can say, is the quality. So under this research niche, there is, we can do psychological measurement. You can actually ask people, you can do questionnaire and ask people regarding daylight performance of a space. You can do modeling of occupant behavior and so on. So, and here there is a study of a human experimental response. So basically you can make perceptual measurements, computational perceptual metrics. So you can measure them also. So this is all about daylight. So it's really as a PhD student or master student, you really need to be aware about what are the possibilities to design your correct research in daylighting performance. At the same time, of course, daylighting is only one metric, right? We have also energy, right? Energy is very important in the building. That's why if you take a look here, you can see also in energy we can apply, for example, simulation. We can do simulation. We can do field experiments regarding the energy consumption and field studies and so on. I think I will not keep reading all these. There are too many. I will just, I hope you got an overall idea regarding that it's very important to understand the niche of possibilities so you will be able to design a research. Because if you are a PhD student, I know maybe you still didn't read too many things and you will think only simulation exists in the world. But no, there is too many niche actually you can go through. So it's good to know the overall idea. All right. If you have any questions, please, you can put in the comments. Now, when we talk about simulation versus experiments, remember, experiment, it can be field or lab experiment, right? For example, this simulation, this experiment, as you can see, we are trying to do an experiment to simulate in real life the behavior of this structure versus the earthquake, right? As you can see. But this is a lab. It's like a laboratory, right? It's not a real building, as you can see. They really created a model in under a roof, as you can see. There is a really big building, this one already, and this one is inside this big building. As you can see, the scale of humans is very small. So this research team, they decided, they think that for them, it's better to build a real building. I believe it's in Japan. Japan, generally, they are really crazy in this kind of idea of research. So here we can see experiment in the lab. And here we can see simulation in a computer. So now the question is, what are the advantages of performing simulation or experiment to measure maybe the impact of earthquake or doing just a simulation? You need to ask yourself. So anybody has an answer about this, please, I want participation. Hello? You can also comment, if you don't want to talk, at least you can comment, please, so we can move. So what are what are the advantages or disadvantages of each method? Experiment or computer simulation? Okay, someone said simulation. We can test the what is it? Where the comment has gone? Simulation, we can test the limits with low cost. That's very good point. So Abu mentioned that simulation is not costly apparently, right? It's very clear, right? If you to build this real model, it's actually thousands of ringgits, but this one maybe only 2% of this one because it's all virtual. So what else? The limits of the design he mentioned. So I don't know exactly what they mean. Do you mean that the design will be limited here or what? So others, please participate. So the more you interact with me, the more you will get good feedback, and I will arrange the lecture to serve you. But if you are passive, I cannot really. I don't even see your face, so I can understand if you understand or not. Yeah. Okay. Very good. Very good, Prof. Nankola. So he mentioned that we get results fast. I believe he mean in simulation, right? Because this one already, in order to build it, maybe you'll need months to get it. But this one, basically maybe few days or few weeks, you will get the model and you can test and see the results. Destroying an actual building, someone said. Test the structure without destroying an actual building. Please, when you please be clear, because right now I need to guess actually about what you have written. So test the structure without destroying an actual building. Here, of course, we didn't destroy any actual building. This one, we built it. Unless you are thinking after that we'll need to destroy it, maybe, right? Okay, this means during the experiment. Yeah, true. So, in other words, I can say it's risky, right? There's a risk. Anything can happen. If any mistake, if you do a simulation like this, experiment like this. This one, of course, nobody will be hurt because everything is virtual. So please mention the disadvantages and advantages. Not only you need to compare. You should not stick to only this one and you give just the disadvantage, because if there's only disadvantages, why on earth they should keep up using it? It seems maybe there is also advantages, right? And one of the advantages I mentioned already is that physical or real world experiment is very accurate compared to this one. It's very accurate, even though it's very costly, but it's very accurate because actually are using real materials and real world physics, not these ones that are really virtual physics of the real world. Okay, I think I can give you other advantages. Basically, for example, when you use simulation like this, we will be able to do design iteration, right? We can change the design very quickly and see the impact on the results, right? One of the other very important advantage in computer simulation. Okay, I will continue because I will go through the similar ideas more and more. Okay, another example. I wanted to start my sharing with the kind of real examples because it's very important to feel the benefit of simulation and the experiments. I don't want to start with the theoretical things because generally this kind of research which are related to building performance, they are really related to the real world. So this means when you get a solution, for example, for the optimized design of your window size, you can really apply it to the real world, right? It's not just a framework or theory. You really can make it in a guideline. This is what we found, and you can apply it in the real world. That's why here you are looking to a case study, for example, which is in Danish regions, and a classroom. And apparently this classroom, as you can see, it looks dark, right? So it's like the lighting is not enough. So this is before and this is after. Look, after some interventions, things they changed drastically. And another thing you can notice, artificial lighting here is on. Artificial lighting here is off. It seems that actually we are conserving energy, right? We are consuming less energy, which is good. One of the objectives of nowadays and sustainable architecture is to reduce energy use. Now, if you are an architect in the real world and they bring you to this classroom, you will look to the problems. Now, what you will do? the first thing you will need to do an experiment. You need to measure, right? You need to measure the performance of existing conditions of daylighting. Usually we have devices such as this one, very basic device to measure the luminance. So basically the quantity of light following on the working plane. So what is next? So once you measure the luminance of the case study, generally you will not be able to, for example, in the real world, you will not be able to test, for example, if I increase the size of this window, how will the daylight improve and will it be compliant to the standards? It's very hard, right? You cannot change the window on site. How can you do that? You want to destroy the window and increase it. So real world doesn't allow you to do design iterations. That's why even though simulation is not that accurate, because it has this capability to create too many iterations and test them, it's still very powerful tool in the hand of researchers in the built environment. So this is what they have done, the architecture firm. This is not a research project, but it's practical in the industry, but it's similar. So basically, after that, they created 3D model of the base case, and they did the simulation for the daylighting factor, daylight factor. I believe you are familiar with daylight factor. As you can see, they found that it's very low. So for example, here, average 1.1, 0.6, 0.8. And basically, according to the standards, I'm not sure about the standards of this Danish region, but in Malaysia, the daylight factor at least has to be in office building, for example, it has to be from 1.5 until 3.5%, the daylight factor. As you can see, this is very low. That's why, as an architect, you will start thinking, how can I improve now, since I have the results in the simulation? I already measured here, and I find, for example, the daylight factor is very low. After that, I did the simulation. So now the good thing is simulation, it will allow you to do experiments virtually, right? This means, for example, you can maybe increase the size of these windows. I know the science seems to be the same here and here, but of course we cannot see the height. So perhaps they increase the size of the height of the window. Perhaps they change the color of materials, for example, here and here, even though I don't think so, but perhaps, right? In research, we can play with the parameters of the materials, like reflectance and this one, visual light transmittance, and all the parameters in the building. Can I ask someone, what do you think, what they have done to move from here to here? Because for windows, they seems to be the same size. So what did they change? As you can see, the daylight factor has increased from 1.1 to 5.7. Please comment, or you can talk also.
Dr. Me can rotate the building if I can by land use.
Okay, as you know, this is an existing building, and I believe there is no monster can take this building and rotate it, right? So yeah, so you cannot propose, as an architect, you cannot propose this solution because it's impossible. It's a fixed building, you cannot rotate it. But of course, orientation is one of the parameters in the design stage, not for existing buildings. Okay, others, please. So we have one idea. So what about others? They painted the walls, floors, and ceiling white to increase the reflectance. I don't think so, because yeah, it's true, it's possible what you are saying, but I don't really think so, because they are still white. Here it's because of the lighting, they look like a bit yellowish. Otherwise, they are still white. I think you can notice. Yeah, so someone said adding light shelves. They open the sky window. Yeah, very good. The correct answer is they open the sky. As you can see, sky windows here. Yeah, as you can see here, it's closed, and basically they open. And they have run the simulation, and they found that basically just by opening simple skylight windows, it's make the daylight factor increase. So you can see that what we have gone through already, it's basically a combination of experiment and simulation. because they did experiment to measure the current situation, daylight factor. And generally, when we do that, I actually forgot one step. Generally, when we do that, we do simulation to measure also the daylight factor. But before we go and start creating new design option, we do what is called validation. You need to make sure that the difference between the measurements and the simulation of the case study, the difference is acceptable. Of course, you cannot find it 100% exactly the same. Impossible. You will find an average difference. It can be 20 to 30%. But according to researchers, they say it's okay if you find it even 20%, you can use that simulation software. If you don't find it correct, you need to calibrate actually the your simulation model with the measurement. You cannot proceed to create a new design option in the simulation until you approve that your software is validated. This is very, very important point. And if you don't do it in your research, the validation part of the software that you are using, everybody will question your research. So other things, as you can see, it's not only about improving daylighting. Usually when you improve or you increase the daylight, automatically will get benefit of reducing the artificial lighting. As you can see, the renovated classroom 24. If you compare here, not renovated, so this is the before. As you can see, the energy or the amount of hours the artificial light is on is too high, right? It's about 3 times after renovation. Similar thing for class 25. So as you can see, it's really benefits for in terms of energy reduction, not only daylighting, as you can see. All right. Since we talked already about, I have already shown you these examples. So these examples, which are kind of more practical. So it's very important as a researcher to really understand what is simulation first, right? What do you mean exactly by simulation? We need to have a definition of simulation. Maybe experiment, it's easy to absorb because you can do it in real life. And you can see this is a model. Okay, you are experimenting, very clear, right? But simulation, we need to ask the question. So what is computer simulation? So anybody can give an answer. Please don't use ChatGPT and Google. Please, either you can talk or you can comment. Feel free, please, to participate. Otherwise, you can listen to me, right? You can hear me. Am I alone here?
Doctor, is there any sound to the video?
No. There is no sound. There is no sound. But I want to hear them. I want to hear the students. Please, either okay. So I think computer simulation can be defined as predictive digital representation of reality. Yeah, very nice, very nice. I can see very important keywords. So prediction is very important, and reality. And basically, without more philosophy, it's what you are saying is correct, actually. Yeah, basically what you are looking to, for example, in this video, as you can see, it's a simulation, actually. It's a spacecraft. It's falling on the water surface of the sea. And the water is really behaving it's like real, even though it's not real. Everything is simulated using a computer. This means the computer itself knows the exact physics of the water and how it will splash on the rocks and how it will behave, basically in very precise way. So this means all the physical world parameter, including gravity, including weight, including material, including water or liquids behavior, they are in the software. Obviously, this is not a simulation related to buildings, right? But building simulation also, it works like this. So you have a building, and the software that you are using already knows the physics of heat, for example, transfer from the outside to the inside. If you are doing computational fluid dynamics simulation, this means the software knows how the air will move throughout the building. So all these parameters and algorithms are really embedded in the software. So you, as a user, basically just make sure you inputted the correct data or parameter, and you run the simulation, and you will get the results like a magic. But basically, there is hard work behind it. So in terms of definition, so computer simulation is the process of mathematical modeling, which is designed to predict the behavior of real world or physical systems. I think Abu already mentioned this. So the only keyword maybe he didn't mention is mathematical modeling. Of course, a software is basically trying to imitate the real world using math, right? So basically there's algorithms in the software to predict how things they will go. So as I mentioned, so always you can take the computer simulation software as a black box. You as a user, there will be an input and you will get an output. Depending on the quality of your input, the quality of output will be. I hope it's clear. So you need to understand that computer simulation doesn't exist only in architecture. In fact, if you compare to the other industries, the built environment is kind of late compared, for example, to the car industry or manufacturing industry. So as you can see, many benefits. For example, for car crash, we can do simulation. We have the model of the building. We have all the properties of the materials, the elasticity, and all the behavior of the material when they crash. And as you can see, some of you will start thinking, this means it will save me from death, right? If you do experiment like this, you will die. However, using the computer, you get results without making anybody RIP, rest in peace. So of course, in aircraft industry also, because aircraft basically the whole concept why it can fly basically is because of the air, right? Pressure. So this means it's very important to really know and do simulation and to improve the shape of the aircraft so it can fly without any issue. Of course, in weather also forecasting, we can do simulation to predict all the phenomena, how will happen, etc. So this means, I believe Abu is saying, so simulation can save money. Already we have seen that. We are not using real materials. It can save time. Already Prof. Nankola mentioned this. Generally, it's not like creating a real model. It can save life. And it can save resources, right? Since you don't need materials, this means you will save resources. You will save human resources in terms of constructing your big model if it is very big. And most importantly, in architecture, it can help decision making. As you know, in architecture, when it comes to building performance, always the goal of the researcher or the architect is to find the best design option, right? To improve the performance. So this means by using a software which will help me to take a decision, make good decision based on data, based on evidence, based on evidence and data. So that would be the perfect scenario. And this is the role of computer simulation and experiment, because sometimes we combine them. Any questions? Okay, if no question, I will continue. Remember, because I already jumped to the simulation and why it's important and what we can do with it. But remember, most of the time, research in the built environment related to the building performance, they start with this big idea, right? They tell you, if you read any paper, you will find that they are talking about the climate change, climate disasters, depletion of resources, etc. And they will tell you, we developed this system, or we conducted an experiment, or we conducted a simulation to investigate what is the best, for example, combination of parameters for example, a specific shading devices, maybe in specific region in the world. So generally, this is the big idea, actually. So again, just to make it clear, based on data, we have really big issue in the environment. So in terms of resources, so for example, 20% of water consumption is from buildings. About 40% is energy use is from building. Imagine 40% of energy use in the whole world is from building. It's really big number if it is 40, right? Greenhouse gas emission, those that are impact or they make the climate change issue. Really big numbers, waste also. And there is a very known saying, so if you cannot measure it, you cannot improve it. So I hope you will remember this, because the good thing, most of the other approaches in doing research in the built environment, especially those that are related to the social science, it's like most of them, especially if you use interview or questionnaire, maybe you will get a better idea when you use questionnaire. But it's very hard to measure things when you are dealing with people. But when we are dealing with the problems related to building performance, you are dealing basically with the building physics, right? This means really you can measure. So all of them, they are equations, they are numbers. And simulation basically is always quantitative. So that's why this guy is saying, if you cannot measure it, if you have a building or if you have a problem, if you cannot measure it, you cannot improve it. And simulation is here to help you to measure it. Simulation, basically, we are measuring virtually, right? At the end of the day, you are measuring virtually. Okay, let's continue. So if anybody of you is interested to perform any kind of building performance simulation, it's very important to get an idea about what are the parameters that we, or the criteria that we can simulate in a building, right? I already mentioned energy and daylighting, but there is many others. So the first thing, of course, you can study. So it depends on, of course, on your research problem. So the first thing, it can be things regarding solar radiation. You know, some path you can optimize, for example, the shading devices, the massing of the building in this category. So these are kind of screenshots just showing things related to that. For example, here we can, for example, optimize the shading devices. For example, as you can see, always we have a baseline here. After that, we propose, for example, create this kind of shading device option. Always we are measuring the solar radiation falling on the on the glazing, and we try to see which one is the best. Of course, things that can get more complicated. This is a very basic issue. Huh? It's not it's not PhD problem. This one, maybe it's not even a master problem, but you know, everything starts from the basic things. Of course, if to make this complicated, you can add more objectives. For example, the view. For example, as you can see, if I use this shading device, it seems that the solar radiation is low compared to the base case, but maybe people, they will not be able to see to the outside. It would be annoying to see all these lines. So perhaps you will try to find the balance, right? So these are kind of research. You can use optimization algorithm to find the balance between two performance criteria, for example, or even more. Yeah, so here another thing related to this solar radiation. So you can do simulation to find, for example, the optimum location of the PV panels. So therefore, you can get more as possible solar radiation, and therefore you will get as more as possible electricity for your PV from your PV renewable energy. Now the next thing is low carbon strategies, and the next thing we can perform climate analysis. So this one is also helpful, not for research, maybe for students working in design studio. This is very good for them. Instead of just saying the dominant wind is east or west, nowadays we have the data actually hour by hour and year by year. Day by day. So it's really data-driven approaches. But anyway, I think we can do simulation for energy and carbon. So you can actually create a model. Nowadays we have these softwares. This is not wow things or new things. Already the state of the art of these things that are really mature. So you can model a building and you can predict how much energy it will consume if you build it. And you can know, of course, when you say energy modeling or energy modeling, generally it depends. It's related also to the thermal comfort. So thermal is energy also, so it's under energy. We can do, of course, daylighting simulation. We can do daylighting simulation, and we can see if our building is compliant to specific rating systems, for example, LEED or BM, UK, etc. Automatically, actually, nowadays you have software that they can find the compliance with the green building rating system automatically, because previously you need to simulate and then you try to compare manually. What else? So things regarding regulation, we can do simulation related to regulation, value and cost. We can also see equipment movement. We can do simulations regarding the occupancy stage, for example, in terms of safety in case of earthquake, any problem happen, emergency. So we need to simulate how people they will run, because you know this is very sensitive. An airport contains hundreds of people, and the crowd can be need to be managed very carefully. That's why we can do simulations actually of these things. Of course, it will never be exactly as the real world, right? You can imagine that you cannot. No software can predict how this guy will run, for example. As you can see in this example, maybe you can see simulation. It will never be 100% correct. It's very hard to make it like the real world, because real world really very complicated. We can do simulation for the HVAC system. So especially those in engineering, they can do simulation for the HVAC system and the energy consumption of it. And those that are interested either in the urban environment or the even the building environments, you can always do what is called CFD, computational fluid dynamics, to study the performance of your building or your interior space in terms of ventilation or wind speed. Okay, so of course we can do also studies regarding the glare. So nowadays we have softwares, very sophisticated softwares actually, like this one, to really predict the problem of the glare in our space in a very sophisticated ways actually. All right, remember now I'm trying to make sure that you really because sometimes in most of the cases you find the student, they are not familiar with simulation, so it's always better to, instead of start talking about the what they call it, the design, how to design the research, I need to make sure you understand, you get an idea, right? What are the possibilities? Okay, so any questions before I move on? Please write your question if you have a question. You can also open the mic. No question, please write no. So at least I know you are here. I can see only Abu is participating. Are you here, Muhammad? Hussein? All right, let's continue. Okay, the next slides. Do you have any question?
No, thank you, Doctor. Thank you. And
Okay. What? No question? Or
okay, my topics in my research is evaluation and development of community-centered water harvesting and flood mitigation concept of housing in Amman. And by this idea, or by know about the simulation, I can build model and compare this model by simulation. And thank you for this idea, for this lecture, Doctor.
yeah. Welcome. But be careful when it comes to simulating the flooding. There is very few softwares actually which they can do, and it's not, for example, like daylighting. daylighting, of course, many softwares, and they are very easy to use. But flooding, personally, so far, I have never used a software can do flooding simulation. I know some softwares like BIM HVAC, software called like this, BIM HVAC, which is developed in Singapore, I believe. It can do simulation for rain, for example, like the rain, how it will fall on your building, etc. But flooding,
Yes,
I'm not sure. So you really, as a researcher, you really need.
maybe Dr. by built 3D model, 3D by DTM and digital elevation model. I can by GIS software build the 3D city and will. By simulation, I can compare this model and test this model. And thank you for this lecture for using this.
True. GIS, I think it has some capabilities regarding flooding management. True. But you need to check. I've never tried that, so you need to check. Okay, thank you. Let's continue. So, so the following slides, they are very, very important. You can say they are some of the most important slides in today's sharing. Why I'm saying they are very important? Because actually, because when I was also doing research myself, sometimes you will feel that it's like you are confused from where to start. What do I need to learn in order to be able to do good simulation? And in the following slides, I can tell you the things that you really need to be good in order to be more confident in doing simulation and building performance related research. So this is the first advice. So something called garbage in, garbage out. You need to know that in the building performance research, and specifically when it comes to simulation, it's very known this is garbage in, garbage out. So when you have a software, if you give the software an input which is not good, which is not accurate, the software will not tell you, hey, your input is not okay, it's not accurate. The software will just give you the output. And so this is very dangerous, right? This means there is a high chance that you will make mistakes and you will get wrong results using your simulation. That's why this is my first advice. Always remember, be very, very careful in your inputs. When I say input, it means the model itself, the 3D model has to be accurate and similar to the reality. The material, so it depends on what simulation you are planning to do. If it is daylighting, you need to be very careful that you are assigned correct materials for the glazing, for the floor, for the ceiling, and all the elements. What else? So also the setting of the simulation. For example, if you want to do a simulation for 12 p.m. in 31st of March, you need to set that, right? You cannot say, oh my God, I forgot I selected June 21st. Software will not tell you you selected this date, but you won't know. It will just give you the output. So these are examples of wrong or giving garbage to the software. Therefore, you will get garbage also. So this is very important information that you really need to remember. Now, the next information that you really need to be familiar with is that if, let's say, we assume that we have this is the building performance simulation box, and this building performance simulation box, in order to be very confident and very good in it, you really need to open what is inside. I can tell you building performance simulation, it contains these things. So the first small box is weather data. As I mentioned early in this presentation, that building performance, almost any, like for example, daylighting or energy, always they will use weather data, right? How can the software do a simulation without knowing the temperature of KL? You want to do a simulation of KL, you need to tell the software this is the weather data. This weather data actually is a file nowadays that you can download from the internet. So basically, almost any location you have the weather data. And so it's very important to understand all the parameters of the weather data. I will show you later on. I will open one by one. Building metrics, physics and metrics. So it's very important to be confident and to know what is illuminance, etc., and different criteria. The third thing, which I think is very important, is building standards. You know, building performance is always related to standards. So, because usually when you do simulation, you will get a result, but after that, the question is, and then you need to compare your results to a specific standard, right? And see if you are compliant to that standard or not. So it's very important. And the number 4 is simulation software and engines. Of course, nowadays there is many softwares that they can do simulation. So as a researcher, you need to know which software is available for you. Not all softwares are free. Some that are free for research, but many of them, they are not free actually. So you really need to know which software and the capability of the software. You need to understand that not all softwares, they can simulate everything. Some softwares that are specialized in certain areas. For example, Dialux is specialized in daylighting only. Other softwares like IAS VE is specialized in all the performance criteria that we have seen already before. So it's really, you really need to decide about that. Okay, let's open box by box now. So box 1, weather data. So weather data, any weather data file, actually it contains all these parameters. One of them, for example, dry bulb temperature. So as a researcher, you need to understand what is it. You should not hope to understand the simulation results and you don't understand the simulation inputs. This is a very big issue. So relative humidity, at least you need to understand how it is calculated basically, right? The percentage, you know, of the humid moisture in 1 cubic air volume. So these kind of things, they need to make sense. Anyway, as you can see, many parameters. All these that are in a file called weather data that you can download from the internet. And nowadays we have softwares that can visualize this like this. So as you can see, this one is the temperature, for example, throughout the year from January until December, as you can see. So this is only one parameter, dry bulb temperature. However, you can visualize all these. So as I mentioned in the beginning, generally this weather data that are really collected using weather stations in different areas. For example, if you download weather data of KL, you can just Google it. Actually, you'll find from where to download it. You need to understand that weather data file is the data of basically almost you can say it's 12 years of data collected using a weather station like this one. After that, they when they collect this data, there is, for example, this website. They put, this is not coronavirus spreading anyway. Each point actually is the location of weather station. So this means if you are working on a project here, you can zoom and you click on this point, and you will be able to collect or download weather data, weather data like this. Of course, this one is KL. This means we clicked here already. So to get Kuala Lumpur. So remember, it's really collected in 12 years, not only 1 year. So 12 years because they wanted to get a representative amount of data. Because, you know, there is climate change already. So you cannot, for example, measure only 1 year and then you measure 1 year, for example, and then you use it for your simulation. There's a high chance it will not really be precise, right? That's why they measure 12 years. Okay, let's continue. If you wish to go to this weather data viewer, if you scan this one, you will be able to go to this website, and it allows you to visualize data. Maybe I will go myself 1 minute. Click launch. So this one is a weather data viewer. So basically, as you can see, let's say already there is some weather data already here. I click Singapore. Of course, if you have your weather data, you can click here and you load your weather data that you have downloaded already. And here, as you can see, it gives you the dry bulb temperature of Singapore from day 1, January, until last day of December. So it's good to visualize and take a look to the data, the average temperature, etc., and many data, as you can see here, even things regarding wind speed. Can show wind speed, for example. Here is wind speed. So this is real data, not just for showing things. Even snow, of course, Singapore has no snow, right? So that's why basically there is no snow. Of course, if I change it to London, it has snow, right? As you can see, snow will start from February, about 2 centimeters of snow, actually 4 centimeters. And it will go about 2 in average centimeters of snow. Anyway, I will not spend time explaining this. You yourself, you can go and open it by scanning this QR code, or actually I can put it in the chat. So you can just go and select chat if you want, but maybe I will give you 2 minutes to go through, otherwise you will not follow the next slides. So this one is a weather station in MIT University, and it has live data actually. So if the problem, yeah, I need to scan this one also. I didn't put the link. Of course, anyway, you can scan, you will get weather data live, collected live on top of the roof of MIT University. And the time is like 12 hours, I think. It's like 12 hours before you will see the data. If you go to this, website, which looks like coronavirus map, you will be able to download weather data, let's say from Algeria here. So this one is Elwood, where I stay, my home somewhere here. So maybe I'm designing a building here or doing a research here. So I need the weather data, right? I'm not sure if, okay, let's download it. Sometimes some weather data will not be able to download, so you need to find them somewhere else. I will put this also in in the chat. It's in the chat already. Of course, as you can see, I can download it now, and then I can bring it to the viewer if I wish. Here, I can after that look at it. So load weather. You can actually, as you can see, there is even weather stations. Apparently, no, you cannot. So this means you need to load it. Anyway, okay, let's stop regarding this. Otherwise, we cannot move on. I just want you really to understand that any building performance research, you really need to understand that usually we use weather data when it comes to simulation. Any question? Okay, no question. So the other second thing I think is very important is building physics and metrics. So if you are doing, for example, research in daylighting, you cannot start doing research and you don't understand illuminous. You don't understand luminous intensity, for example. You don't understand the different units of these. If you start working on that and you don't understand, of course, you will not be able to progress. So it's very important actually to make sure you understand at least the different parameters, the different metrics in building physics related to the simulation that you want to run. For example, if Mohammed Hussein want to really run a simulation related to flooding, this means you really need to understand the physics of liquids, right? CFD basically. And after that, you will find the software that it can do it, etc. So this is very important. So it depends. If energy, you really need to understand heat gains and heat loss. Please make sure you really open this box, building physics and metrics. Now, second thing, so building physics and metrics, you really, for daylighting, for example, there's too many metrics you can use to simulate daylighting. So, for example, there's luminance. You need to understand how it is calculated. There is daylight factor. You need also to understand how it's calculated. Even though the simulation software, you just click, you will get the results. But if you don't understand the theory, how it is calculated, how can you really interpret the results and how the results will make sense for you? Now, special daylight autonomy is, for example, another metric. So you really need to understand how it is calculated, even though the software, again, it gives you the results automatically. But if there's the metric doesn't make sense for you, theoretically, it would be hard to judge what you got actually. Now, the third building, the third box, I said you need to open is building standards. So building standards, basically there are building standards, and there is local standards and there is international standards. So usually, for example, local standards, if you are working on daylighting or energy simulation, you will find too many standards regarding that kind of simulation. So if you are doing research in Malaysia, for example, it's impossible if you do research in Malaysia and you don't open this standard. If you are doing simulation or building related performance, you really need to open the standard and see what are the standards according to Malaysia. Here we have international standards coming from ASHRAE. So if you are working on energy standards based on USA or thermal comfort, we have standards, things regarding to air quality, things regarding to minimum indoor air quality performance here also. So this one is more towards air cleaning devices. So you really need to have an idea about these things. I think, any questions? I think we take a break, 5 minutes. If you have any question, please you can put in the comments. Okay, someone said, how accurate are global climate models? How can we know that the scientists are not putting garbage in their simulation and getting garbage out? So you don't trust people to this extent, you? Well, at least because of course, generally the scientific community is there is a trust, right? Because if you remove trust, actually, if you remove trust from science and all the publication, this means any paper you read, maybe you can say, no, they are faking the data, for example, the data is fake, because you can fake the data and make research, right? But if you keep thinking this way, this is not the correct way to think, because initially we are giving or we are putting trust in the scientific community. I'm not telling you this means nobody will make garbage in the data. Of course, some people they do that, but if we work with the way that there is no trust, it will not. That's not the best approach. Of course, another thing you need to understand that this climate data, weather data, you can get them from really what they call them, very recognized organizations actually. For example, ASHRAE, this one, American Society of Heat and Refrigeration and Air Conditioning, etc. This is a very recognized internationally organization. So basically anything they give you, by default, you need to take it. Did I answer your question? Are you here? Okay. What do you mean? I trust the scientists, but I don't trust the media so much. There is no media in weather data. Or you are talking about climate change or what? You can talk. You can talk directly. You can talk. You can talk. So we.
You use the mic?
Yeah, of course.
Yes.
Yeah, please explain your point of view.
Yes, I trust the scientists, but I feel that the media likes to hype things out of proportion.
Anyway, as I mentioned, weather data has nothing to do with the media, and of course, the climate change story is it's another story. Actually, it's not really
It's a different
because in the
topic.
end of the day here we want to use data to do simulation. After that, you believe in climate change or not, that's another issue, but it has nothing to do with what we are doing. Yeah, because we are trying to use data to predict the performance of the building, even if there is no climate change. For me, wisely speaking, a building which consumes less energy is better than one which consumes more, right? Even in terms of cost. There is cost change, right? You believe in cost change.
Yes, definitely.
Yeah. Anyway, I think you will take CAMS with me this semester, right?
Yes, I will.
We will discuss that topic.
Okay. Thanks, Doctor.
Welcome. So others, any questions? Okay, if no questions, please just write here or something so I know you already came back so we can continue.
Hello.
Yeah.
Hello.
Yes.
Thank you very much for sharing all the data. I wonder, can I get help from you to share about the where can I get some statistic data analysis website? Could you share some website like the population of the dialects range and also like many other data like I can sum you out like statistics. Thank you.
Actually, of course, if you are doing research in building performance, if you want to do experiment, generally you need to collect the data yourself. Generally, it's you who will collect the data. Generally, you need to understand that as a PhD student, actually you can borrow these devices. Don't think only, I don't know, those big organizations, they use these devices. So you can borrow this device and it's up to you where to put it to measure, to collect data. You can put it inside, I mean, a building, maybe even maybe in kind of in a park. It depends on your study, of course. It depends on your search question and objectives. So you yourself, you can collect data. So and generally nobody will collect data and put it online for you. And also, if, for example, someone collect the data in England and put it online, you will not need it, right? Since you are working in China, for example, you cannot use that data. It has nothing to do with the. So again, it's responsibility of the researcher himself or herself to collect the data generally. Did I ask? Did I answer your question?
Yeah. Thank you. So this one called the weather station.
Yes.
US.
Yes.
Okay.
Generally, generally universities already, they have this. I'm not sure in UCSI if they have it or not. I'm not really sure, but it's not, I mean, it's not that expensive. So basically you can get it. So as you can see, it has some sensors regarding the wind speed. This one will rotate based on the wind speed. It has some sensors regarding the illuminance, the global illuminance, etc.
Oh, I see.
Yeah. So generally for experiment, you need to collect your data, but for simulation, you can use the weather data for simulation. But experiment generally is related to the current situation. Okay, any other questions?
No, thank you.
Okay, others are here. Please, if you are here, please mention yourself in the comment at least. Say yes or say anything. So nobody is here. Means I can see 17 students already. So why? Okay. Okay. I hope you are here anyway. So I will continue. So the next box you really need to open and look at it if you are really planning to do any research related to building performance is this box. So obviously is the simulation software and engine, right? So here I'm giving you a table which shows different softwares. For example, Design Builder, Energy Plus, even though it's an engine, ISVE, Open Studio, all these are very known softwares actually, but I'm mentioning with green are the most known ones you can say, and the most used in the research and in practice. For example, if you see Design Builder, you can do energy simulation, you can do thermal, you can do daylighting, you can do things regarding environmental emissions. However, you cannot do life cycle analysis, but you can do these three and so on. So you can read yourself. You can compare it, for example, to IAS. IAS, for example, can do life cycle analysis. Of course, it can do daylighting, etc., but it cannot do all these. Cloud compute, okay, these are functionalities that are not really. You can do also uncertainty and sensitivity analysis in Design Studio and Design Builder. So it's good actually as a researcher because there is too many options to choose from. You need to really to understand the capability of the software before you start learning them, right? Okay, so I will move on. Here is just regarding the difference between software and engine. I think, I think I will just move because it's more related to the previous one. This is a bonus bonus box. So box number 5. I really believe that in order to find energy performance research easy for you, because when it comes simulation, maybe it's not hard when you run it, how to run it. It just requires time to learn how to run it and make sure the input is correct. However, sometimes the issue is when it comes to, for example, the validation stage, comparing the simulation results to the measurement result. At that time, you will need statistics. You cannot run from statistics. They are basic statistics, but they are really very used in research. So things regarding, for example, the RMSD, so root mean square deviation. So this one, it will give you an idea about the deviation between the simulation results and the measurement results. And based on that, you will see in the literature if your results regarding the RMSD is acceptable or not. And you will write this in your thesis. After comparing the simulation results and experiment results, we applied RMSD. We found, for example, the difference between simulation and experiment is 30%. According to X author, 30% is acceptable. So from 20 to 30, for example, is acceptable. Therefore, we decided to use this specific software to create more design iterations, since we validated the usefulness of that specific software in that specific problem. So here I'm showing you only two metrics related to statistic, like this one, least square, so RSS. So sorry, residential sum of squares, RSS. So it's really you need to read about these, and they need to make sense for you. Otherwise, it would be hard which one you will decide, and which how to argue that you use this one or both. So this is what so far I think these are the main 5 boxes, as you can see. So basically, if I go to the boxes here, so basically whether data, remember, you need to understand all the parameters, building physics and metrics, building standards, simulation and software, and the bonus box is statistics. Okay. Okay, now there is one slide which is generic framework for building performance simulation. I can give you the slides anyway. I can give you in the slides in I think issue, right? The name of that platform. Because I think I will not spend time explaining this, because this one is more related to a design studio project or a practical project. But I think you, since you are all researchers, better to show you how we can apply, or the general framework of applying simulation or experiments in the research project instead of practical project. So this is what I think. So the overall design. So if any paper you get it and you read it, you will find this framework or this process, or at least part of it. Please follow. So of course, the first thing you will need, you already fixed a specific problem, right? So you have a research problem, and of course you have a clear research objective. So after that, you will start investigating that problem. So at that time, we have 3 options. Either you want to start or do only computer simulation. It's possible to use only computer simulation, or you will use only field or lab experiments. It's also possible. Or second option is combination of them, simulation and experiments. And this is the most powerful approach. I'm saying the most powerful approach because many high-ranking journals, if you submit only computer simulation, they will tell you, no, you need to bring the experiment also. Most of the high-ranking journals, they really want combination of simulation and experiment. I'm not telling you you will never find a simulation-based approach only in a paper. You can find that, but there's a high chance they will reject your paper, just not because the simulation is not good or anything is not good, just because they want more kind of complex approach of designing the research. So similarly, for your PhD research, for master research, I think simulation approach only is very good for master level. Of course, experiment is always good. Even by itself, experiment is always, it makes sense more than simulation actually. However, in what they call it, in PhD, this would be very powerful if you really apply it both. Okay, let's say someone in master, let's say, is working with computer simulation. So the first thing, already you define the problems, etc., and the objective. So you will need to define the performance objectives, right? Based on your problem. This means if you are planning to do any simulation related to daylighting, you need to know what are the metrics you want to simulate. You need to define the objectives of daylighting simulation. You need to know, do you want to increase the quality or the quantity of daylighting or what? These things, they have to be clear. After that, you need to define the parameters, right? So you cannot run a simulation and you don't know what are the parameters you want to investigate. Is it the color of the material? Is it the size of the room? Is it the orientation of the building? Is it the size of the windows? So as a researcher, it's your role to decide. Of course, and generally you need to decide based on the literature, right? You should not invent the wheel again. So if you see a gap in the literature that they didn't study this parameters or this combination parameter, you can decide and you can argue in your thesis. So generally after that, you are ready to run a simulation. Generally, as I mentioned, there should be a baseline when you run a simulation, and you need to run a simulation for different design options. So you need to really to create design iterations of different design options. Why? Because later on you will need to compare the performance, right? So this means you will say design option 1 performance is better or higher than the baseline 10%, for example. Design option 2 performance in terms of daylighting, let's say daylight factor, is better than this one in terms maybe 5%, etc., etc. So after that, you compare the performances, you do your analysis, and you get conclusions. So generally, if you are in master thesis, most of the time is very good research if you just follow these. Okay, let's say someone else is interested to do field experiment or lab experiment. So in the built environment, when we say field experiment, this means usually it's a case study. This means you visit a building representative of maybe the typical office building in Malaysia or typical residential apartments in Malaysia. So it depends on the problem that you are investigating, and you will do measurement, which is basically the experiment. However, if it can be also a lab, so this means it depends again on the problem and the objectives. So if you are investigating daylighting, so in some universities they have labs where they have artificial skies. They have labs where they have there's artificial skies and artificial. I think most of the time the artificial sky when it comes to the built environment related to the daylighting, of course. Yeah, so you can use it, and that would be a lab, not a field. Similar thing. Performance objective, they have to be defined. Design parameter, they have to be defined. So here, as I mentioned, either you select a case study or a lab physical model. So you create your physical model in maybe an artificial sky if it is daylighting. You perform measurements, compare the performance, do the analysis, and get conclusions. Which it depends. As you can see, it's hard in this kind of experiment. It's very hard to do design iteration. It's very hard, right? If you build a model, to start changing the window size, for example, in your small model, it's really not easy. That's why it would be very good to combine it with simulation. So remember, here it's the PhD level. So if you combine it with simulation, this means already you will need to do software validation. So basically, you will compare the simulation or the simulation results. You compare them to the experiment results. So once the validation is approved, after that, you will be happy to create design options and continue with this process. Even though you started, then you have done all this, you will, instead of getting conclusion, you will stop here, or maybe here in the analysis. Okay, let's say here, compare performance, and then you will basically see what happened to the design iteration and performance that for each design options. So as you can see here, we are really, it's a combination. As I mentioned, this is the most powerful approach, not only in architecture, in all disciplines, actually, even in mechanical engineering, civil engineering. Generally, it's preferable to apply simulation and experiments. Of course, this is one of the most important slides in today's lecture. I really hope it makes sense for you. Any questions regarding this? Because I still have only a few slides and we will finish actually. Just show you a paper published in a very good journal. I show you that what I'm saying here already is applied in different studies, very high-ranked studies actually. So you should not worry. I mean, you need to be confident actually. So it's about time. Just need to learn. Just make sure things that are clear for you, things similar to what you have seen today. After that, you can actually also publish in this kind of good journals. Okay. Okay. That's saying it's clear. Okay, that's good. Okay, let's say, for example, this paper, for example, it has been done by my co-supervisor during my PhD years. So dynamic internal light shelf for tropical daylighting in high-rise office buildings. So this research, basically, we read the title. It seems that the researcher wants to investigate the performance of dynamic internal light shelf performance in terms of daylighting, as you can see. And the case study basically is the real project of high-rise office buildings. So here we can see the different images of these office buildings. See? So from here you can start thinking maybe this researcher will apply experiment, right? Usually when we show picture of a case study, real case study in a publication, generally it seems we really apply experiment. And generally, since we really want to find the best option, that time we really need to apply simulation, because using a physical model, it's very hard to do design iteration. And this is what we have done. So we have a base case. So this is the design of the base case. And here is the performance measurement. And what we have done, as you can see, the researchers decided to build small representative model of a specific room in those office building. Of course, you should not create a model of the whole building, right? So it really depends on your design, in your research problem and objectives. And based on that, you create the model. So as you can see here, we have delta OM. So basically, it's a tool or device to measure the external illuminance, sorry. So the global illuminance. And here we have another one, so internal one, to measure the illuminance, the internal one. So using this, we can later calculate the daylight factor. So the next step, as you can see, we created new design options. Why we created the new design option? As you can see, we have 10 design options. This is the base case without this internal shelf, and here with the same shelf, light shelf, but as you can see, we are playing with the variables. Here we created two different variables, different size, etc., etc. So basically, this researcher decided to create 10. So now, as you can see, it seems maybe the next step is to run simulations, right? Since we did the measurements and we validated the software, I'm sure this guy validated the software already. So as you can see now, this researcher has conducted simulation for all the types, or all the options that you have seen here, for different types of for different time of the year, etc. So it really depends on the research design. And here, as you can see, we have data regarding the average daylight ratio for different, I think for different times, right? So as you can see, this is December, June, and March. Yes, and here we have different cases. So anyway, so here we are analyzing the results. So we conducted the simulation, now we are analyzing. And the next, or the last think, since we have already simulation software which we have validated compared to a model, physical model, so field study we can call it, or lab study anyway. Yeah, so he created the small model in the outside. He used like the real weather, real data, not in artificial sky. Actually, he used the real sky. So here is time for the conclusion. So the best performing design option based on all these steps that we have seen here. And according to them, I think they found that LS4 is the best option compared to the baseline. So LS4 is this one. So this is the best option compared to this, compared to this, compared to this, etc. So best option in terms of quality of daylight and quantity of daylight. Of course, if you want to read the paper already, you have seen the title there. So this is the title. Yeah, so I think that's all. Almost 2 hours. Okay. So I've finished already. So if you have any questions, I'm here. Do you have any questions?
Okay, thank you very much, Dr. Taki, for the lectures. Wow, it's been a very quiet class. Huh? Sorry for that. Okay. Uh, uh, is that all, Dr. Taki? Anything you'd like to share more?
No, that's all. I mentioned if any questions from them.
Okay. Any questions from the students here? Okay, I think they might be shy to ask questions, but it's okay. I mean, we have a recording of these sessions. Yeah, I think I will share to the participants who would like to get the full recording of this today's lectures. And I would like to extend our appreciation to the Tatakis, yeah, for the lectures. Honestly, I learned a lot from your presentation there in terms of simulation and everything. And actually, it's not as what I expected. Yeah? I think we today's the Tataki have shared a lot of inside information in which the simulation and also the experiment is actually is not as I thought before lah. Yeah. Okay. I think without
What do you mean? What do you mean? Sorry, Prof. What do you mean? What do you mean? It's like it's not what did you expect? Do you mean you complicated, or what do you mean?
No. Based on my experience, yeah, I examined some students in the. Actually, I have a questions, yeah, for you. Based on my experience, when we have sometimes, for example, like in the literature review, we know that if for example we put a green roof or green walls into a buildings, normally from the literature we know that it will reduce the heat, the heat, whether is it the energy usage and everything, yeah. But I was wondering because sometimes I saw some of the students, if they know already the situation on that, but they still do simulation on that particular thing. That's why I was wondering. I just examined, I think, two students, yeah, from one of the university at the South Malaysia. I told them, you already know that. I mean, she did three sample of house, yeah, in the areas. Yeah. One house with the green roof, the other one with the green wall, the other one without anything. In my opinion, you already know that if we put a green roof or green wall, it will reduce the temperature. But in the research, she still did a simulation on that. So in my opinion, it will, as you mentioned in your presentation, it will be better maybe if you can change the variables, like you would like to know more, maybe you on the vegetation, maybe you would like to know about the positions, the design of it. So I do not know. So it seems like many research that I found would just use a simulation. So I don't know. Have you experienced this kind of research, Dr. Taki? In your, I mean, in your because this is your field.
Actually, of course, without talking about building performance, you know, in research always you cannot keep repeating things if you are doing a research which has been done exactly previously, so there is no benefit, right, to do it. But yeah, but sometimes in building performance, sometimes you change only two or one parameter. You can say it's a new research. Nobody has done this exactly. So therefore, the students that you already mentioned, if they are really just if it is master level, actually, even if they are repeating similar research, I think it's not a big deal. But if it is a PhD, no, it has to be. They need to really to argue. They need to argue in the literature review if they need actually to review all the studies regarding roof design. Even though I know you mentioned it's obvious, but when it comes to, you cannot say simply it's obvious. I know many things that are obvious. I mean, you say obvious, but when it comes to science, you need to bring numbers. You need to know, for example, how much the energy reduction will be. Nobody knows it. It's not obvious, that one. But when you bring evidence that energy, when you put, for example, a green roof with a specific parameters, it will reduce, for example, 25. That's a finding, and you can even put it in guidelines. So it's important thing. However, if already has been done before, of course, you are bringing the same findings now. So what is the benefit? So that's why in the research review, they need to make it very clear. These guys, they did this, they found this. These guys, they found this. This guy found this. Our research, this is the difference between our research and their research. This is our research gap, basically. I'm not sure if they really have shown that or not. Because in PhD level, they really need to show that, right? Otherwise, and sometimes, yeah. And yeah, because sometimes, and sometimes in some research, because sometimes we can do simulation using a software. So basically, just give the data and it will give you a simulation. But sometimes there is another type of research. It's like we use new algorithms, for example. So especially those in engineering nowadays, you know, you maybe heard about this machine learning, etc. So they use algorithms, specific algorithms and they check if they are good in finding the optimum solutions, for example, for roof, for example. So at that time, if nobody has used, even though you are investigating the same problem, but you are using different approach, that's a new thing. So it's acceptable also. Yeah, so it really depends if they really reviewed well the previous studies, and if of course, if everything is similar, it should not be correct.
If for
so
example,
someone said
they just use the same research. They change the some of the variable, for example, some people, they use 3 meters wall, I mean the wall of the buildings, 3 meters wall. The other one put 4 meters wall. So is that a significant significant result for the PhD level? Sometimes I was wondering, because some student, some student, the other one that I found, they just change the, even, you know, the louver. Sometimes you put the louver on certain degrees. They just change the degrees of that particular louver. Is that I mean, for me, it should have a kind.
I don't know. They need to argue. It depends. they need to argue in the. Of course, it's not just changing parameter like this. It's like previous research they used one, let's say, a 20-meter thick roof. You use 30, and you tell me you found it. It's good. It's not. This is very basic, right? It's not. This is not research. So they need to be a kind of a discourse and argument about the process of really reviewing the previous research and designing a research which will really bring good contributions, not just simply one parameter like this in a silly way. Yeah, so it has to be. Yeah. Let's see the comments. So someone said.
I think got
Since
question in the chat box.
Okay, since the ChatGPT and AI is on the way, do you think the BIM still be active for how long? Um, actually, in fact, nowadays many research that are integrating AI and BIM. So it doesn't mean BIM is something, AI is coming. This means BIM will no. Actually, it's an opportunity to integrate the two things. Actually, myself, I do research related to BIM and AI. So we try to use algorithms to do optimization based on the BIM data. So I hope I answered your question. I need to use a simulation software to study the effect of distance of shading device from window, the presence of airflow and heat. So I'm still studying Open Studio, Energy Plus, and about to study CFD to understand which one can simulate this simulation. So to study the effect of this. If you have any experience of this situation, can you please share? Let me please remember what I have read. I forgot already. I need to use simulation software to study the effect of distance of. What do you mean distance of shading device? Do you mean the depth? What do you mean? You need to switch on the okay, the gap. So it's like here there's a window, so shading device gap like this. But why do you think it's important to? Because if you create a gap, why do you think it's important to create that gap? You can open the Mac, huh? Okay, so the gap between shading device and window, because there is possibility of heat trapped in the gap. Okay, are you talking about vertical shading device or horizontal shading device? Because horizontal shading device, I think we cannot create gap, right? Because no heat can trap there. But maybe vertical ones, right? You're talking about vertical ones? Are you talking about vertical ones? Egg, crate, horizontal and vertical. Okay, for horizontal, I cannot imagine how the heat can trap actually, because horizontal is going this side. So if you open it here, well, I don't really see. Maybe vertical if they are really dense, maybe. And generally, since they are open, generally the shading devices that are not really closed, right? Generally, air can move. So are you sure? Are you sure there is certain studies they are investigating this kind of issues? Because you need to understand that better to avoid ideas coming from you. Generally, better to see in the literature. Is the community really interested in investigating this kind of parameters? Did you find papers really studying this? I've never seen this myself. I know for double walls, etc. Yes. About this, yeah, double envelope design. Yes, but shading device, it's totally different than double envelope, right? Double envelope, it's really basically it has only opening in the button so air can move like this. And be careful, the double glazing, sorry, double envelope. Generally, it's used in Europe a lot, but be careful in climate like Malaysia. So far, I didn't see people. Of course, maybe there is some studies, but be careful. Perhaps it doesn't even work. Okay, going back to your question now. So I need to use simulation software to study the effect of distance of shading device. Okay, the presence of airflow and heat. Okay, so I'm still studying OpenStudio, Energy Plus, and about to study CFD to understand. Okay. Mm. Study the effect of distance. I think of course Energy Plus by itself you can since OpenStudio is based on Energy Plus, right? So actually you can do simulation, similar simulation I'm talking about. So airflow and the gap of double envelope. I don't understand the gap between shade and device, so maybe I'm not familiar with that. Yes. Yeah, and also CFD. I forgot there is one software is really specialized in CFD only, and it's really for research, but I really don't remember. But I think in the IAS also, IAS VE, so you can get student license. I think it's 300 ringgits per year. I think it can help in this kind of simulations. IAS. Personally, I didn't use it, but I remember I've seen some papers. I think they have similar problem, similar design. Sorry, problem that are investigating. So I think IAS it would be a good option for you. Okay, we'll consider it. Okay. If you want to investigate more, there is another software called the Climate Studio. This Climate Studio works with Rhinoceros, if you know Rhinoceros. So it also. Yeah, true. Open foam, yeah. True. But open foam is not for buildings only. You need to be careful because it's used a lot in bridges and you know in other fields, mechanical engineering. Yeah. So any other questions from others? Yeah, I think if no questions, that's all right.
Yes. Okay. Again, thank you very much, Dr. Taki, for all the explanations, and I learned a lot from you.
Welcome.
I mean, from your explanation and everything. And it actually is not simple, eh? The research in the experiment, everything. So. Okay, I think that's all for today's. Again, thank you very much, Dr. Taki, for the insights, information, enlightenment, then things that you share today is a very enlightened for some of us lah, and it helps us. Okay, and also for the students who's been here in these lectures. Okay, I think that's all for today's. Again, thank you very much for everyone's. I will provide the link to the recording to all. If you like to want to have it, then just WhatsApp me or maybe email me on the text, and then you can have the recordings. Yeah. Okay, I think that's all. Thank you very much, Dr. Taki. Assalamualaikum warahmatullahi wabarakatuh.
All right. Welcome. Thank you.